So today's video will be on terminating, recurring and rounding decimals. Our learning goals for today: by the end of the lesson you'll be able to express fractions as terminating decimals, express fractions as recurring decimals, and you'll also be able to round decimals. Okay, so some key ideas about terminating decimals. So a terminating decimal is just a decimal that has a finite number of places. So that means it just stops. So for instance, 5/8. So if you put that into your calculator, you type in 5 divided by 8, and you'd get an answer of 0.625. So you can see that it stops. It's only got 3 decimal places. It doesn't keep going on forever. That's what we call a terminating decimal. Terminating just meaning stops. Okay, we've also got recurring decimals. So a recurring decimal has an infinite number of decimal places. So that means it will go on forever. So it has a finite sequence of digits that are represented indefinitely. So what it means, for instance, is 1/3. So if you type that into your calculator, 1 divided by 3, you get 0.33333, and that would go on forever. So it would just keep going on. So if we use the long division way here, you can see, you've always got that 1 remaining. So you're always going to get 1 remaining. Sorry, so 10 divided by 3 is 3 with 1 left over. 10 divided by 3 is 3 with 1 left over. And that would just go on indefinitely. So it's just that 0.3. So the 3 is the recurring part of that. So the way we actually record recurring decimals, there's 2 different options. It's up to you which way you'd like to record it. So you can put a dot above the digits to show the start and the finish of the recurring decimals. So for instance, with our 0.3 example, I'll write up here. So with our 0.3, it's reoccurring, so we can write 0.3 and just a dot over the top, which means that that 3 is going to reoccur forever. Or if it's a sequence of recurring digits, so for instance with this one here, we've got 0.34124124112. We can see that 412 pattern is going to repeat forever, so that's going to be recurring. So we put a dot above the 4 because that's the start of the repeating sequence, and then a dot above the 2 because that's the end of the repeating sequence. So it means that sequence is going to repeat. So alternatively, we can also put a horizontal line. So back to our first example, 0.3, we could also put a line above it like that, and that means that 3 is reoccurring. And for the cycle of repeating digits, so 3, 4, 1, 2, 4, 1, 2, 4, 1, 2, 4, 1, 2, etc., we can just put a horizontal line above the 4, 1, 2 that shows all of that is reoccurring there. Okay, and rounding decimals. So hopefully you have done this before. Like I know we always round during exams or during class, or if we always round to 2 decimal places. So if it doesn't tell you where to round to, I would always round to 2 decimal places unless you're told otherwise. The only exception to that is if you're using a number in multiple calculations, leave the whole number, don't round it, so leave the whole number in your calculator and just work from there. But with rounding decimals, what we do, it involves approximating a decimal number to fewer decimal places. So rather than writing out 8 decimal places, we'll only put it to 2. So when rounding the critical digit is the digit immediately after the rounding digit. So what does that mean by the critical digit? So if you had a number, there we go, like the one they've given us here, 51.34721, and you were going to round that to 2 decimal places, then the critical digit is immediately after the rounding digit. So the second one would be the rounding digit, so that would be the rounding digit, rounding, and the one after it, which is our 7 in this case, would be the critical digit. So that's the one we're going to look at. If that critical digit is less than 5, the rounding digit is not changed, so the second one would not be changed. But if that critical digit is 5 or more, then the rounding digit is increased by 1. So in our example down the bottom here, 51.34721, 4 is the rounding digit and 7 is the critical digit. So if we're rounding that to 2 decimal places, that is, and 7 is obviously greater than 5, so we would round that to 51.35. We'll have some worked examples here so you can have a look at a few more. Okay, so some worked examples here. Convert the following fractions to decimals. So 1/4. So in your calculator, you just type in 1 divided by 4, and you get an answer of 0.25. That's for A. For B, you've got 7/8, so 7 divided by 8 into your calculator, and you get an answer of 0.875. Okay, so then we've got express the following fractions as recurring decimals, so 2/3. So 2 divided by 3, that's what you put into your calculator, and you're going to get 0.6 reoccurring, so you can either put a dot above it, or if you prefer, you can put 0.6 with a line above it. Just one thing I wanted to point out with these recurring decimals, in your calculator, so for instance, if I look at my calculator now, it says 0.6666667. So what happens is your calculator is actually rounding that for you just because it's an infinite number, so it would go on forever, but your calculator screen obviously can't hold an infinite answer, so it will have to round that answer. So your calculator may actually round an infinite, a recurring decimal for you, but it will not round it very, it won't round to 2 decimal places. Like I think I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, I think it's around at 10 decimal places, which isn't very practical. So it's still a recurring decimal even if your calculator rounds it at the end of the screen there. Okay, so our second one is 3 and 5/7. So all that means is the 3 is going to be our whole number there, and the 5/7 is going to be the decimal part. So 5 divided by 7 is 3.71428571428, and that's going to keep going on. So we've got a recurring part there, so we're going to write that as a recurring part, 714285. 8571428. Sorry, so that's reoccurring there. So we're going to find the part that's reoccurring. So, and put a line above it there. So we don't have to keep writing it. So in your answer there, you can just write the part that, the part before it keeps repeating. There we go. So I just write my answer as that. So I've rounded it so we can see what's reoccurring there. Okay, so our further worked examples, round each of the following to the specified number of decimal places. Okay, so we've got 15.35729, so 3 decimal places. So that means that 7 is going to be our rounding digit and 2 is going to be our critical digit. So we're going to look at our critical digit. Is that less than 5? Yes, it is, so our rounding digit is not changed. So our answer would be 15.357. So it will stay like that. 4 decimal places, 1, 2, 3, 4. So this is the rounding digit. And we're going to look at our critical digit, which is the one beside it. And is that less than 5? No, it's 5 or above. So that means we have to round the one before it. But the one before it is actually a 9, so if we round it, it's going to go up. So that will just have a flow-on effect. So we'll look at the one even before that, and that's the one we change and move up. So it'll be 4.862. And the reason it's an 862 is because that 9 has rounded up, and it's carried over to the next one. Our next question, it says to write 3/7 as a decimal corrected 2 decimal places. So in our calculator, we just write in 3 divided by 7. We get an answer of 0.4. I'll write out 2857143, etc. Okay, so we're rounding to 2 decimal places. So this is our rounding digit, and our 8 is our critical digit. 8 is obviously greater than 5, so our rounding digit goes up by 1, so it'll be 0.43. There we go. And that's all I have for today's video.